for now to address the issues and the lessons from two wars, because we know that recent conflicts have rewritten the rules of electronic warfare, and to understand better what all these lessons mean. From an operational vantage, I am glad to welcome on stage Mr. Matteo Merialdo, Director for Technology and Innovation at Nexova, our sponsor. The crowd is wild. Mr. Merialdo, you have over 20 years of experience in the field. You're an acknowledged expert. Proof is, you already were on the stage, I think, last year. An acknowledged expert on artificial intelligence and cybersecurity, recognized by the European Commission. You were last year, if I recall correctly, a cybersecurity principal and now director for technology and innovation. Congratulations on the promotion, and we are utmost glad to listen to what you have to learn us and what you took from those two wars.
Thanks a lot. Thank you very much. I hope that you can hear me. Let's see if this works. Yes, very good. So, I think at the past 3 editions of CYSAT, I always spoke about digital twins. This time I will not even mention once. Well, maybe once I will, but just once. So the idea of this talk is linked to a research that I'm doing partially with the company, Nexova Group, which is part of the Starion Nexova Group, which is part now of the CS Group, which is part of Soprasteria Group. So just to give the picture, now is complete. So I'm doing this research partially with the company and also partially throughout my PhD thesis with the Military Academy of Portugal. So it's a little bit of a combination. So we decided to invest on unmanned vehicle security and, of course, their link with the space security. And I will try to explain how the two aspects are quite linked, and I will give as much as possible updated data related to what is happening in Ukraine, what is happening in Iran, trying to really be as much as possible up to date. I hope it's going to be interesting. Something important, the slides are quite rich of content. I think you will be able to get them, but of course I will not be able to spend more than half an hour on them, so don't worry. But there is content, there are information which I think are quite interesting. So let's start. Why do we say that drone electronic warfare is also a space problem? Well, for various reasons. Modern UAVs, UXVs, UGVs, UUVs are using quite heavily space services. They're using space services for positioning, navigation, that's quite clear, short range, long range drones, they're quite a huge use. But also for command and control, so for the command link. In some cases, on short range, of course, they can use radio, but on long range, normally they use SATCOM. And also very important, space services are used for intelligence, surveillance, and reconnaissance, for ISR. ISR is one of the domain of modern warfare which has been the most revolutionized by the use of especially UAVs, also UGVs and USVs, but in particular UAVs. And the reason is that commanders can have a situational awareness picture which is way, way, way more detailed than it was before. So an army without this type of devices, without this data fusion, like for example in Ukraine, they develop very fast a system that collects all the data from the UAVs, from the satellites, Earth observation and so forth, and provided a general picture is extremely, extremely powerful. So we can see that indeed there is a strong link between this modern warfare and space systems. And when this link is not there, it is because of a conscious engineering choice. So we decided to cut the link with space services, maybe for short-range UAVs, because the link is contested. So going to the next slide, let's see again a little bit more in detail where modern UXVs are using space services. Well, as I said, GNSS, PNT, SATCOM for C2 and telemetry, maybe in combination. So there are drones, for example, on the Ukrainian side, which are using at the same time Starlink and normal radio communication in order to have more chances to overcome problems related to jamming and spoofing. We will speak about that later on. But then, of course, space services are also used for targeting. And that's also very relevant because not only military data from military Earth observation satellites, but also from commercial ones. We'd also, that we could open a parenthesis about what happened in Iran and the strike over the school that was due to other problems, not due to, it wasn't linked to UAVs, but definitely is all part of the problem because the data that the US used at that moment were data from commercial Earth observation. So that's also relevant. And then, of course, drone armies are using space services for weather, for timing, for all these services. So the two domains are very, very linked. And when they are not linked, as I said, it is because of conscious engineering decision. So when was the turning point? And I believe that is extremely interesting because it really happened in the past 4 or 5 years. We saw increasing use of drones since 2012 and onwards. Of course, the first big drones, military drones, were already in the first 2000. They were used by the major militaries. But after 2012, 2014, the war in Azerbaijan, and so forth, they were started to being used more and more. But nowadays, from the beginning of the war in Ukraine, the amount of data that we are collecting about UXV warfare, it's insane. I mean, it really changed completely the way in which a modern war is conducted. And of course, extremely relevant also is what happened last year in June 2025, the 12 days of Israeli attacks into Iran, where we had thousands of drones which were sent from both sides, and most of them were brought down by electronic warfare. That's very interesting. In particular with the attacks over GNSS and also over, of course, the communication channel for the command and control. And then the last war in Iran, unfortunately, February up to April, up to now is not clear, of course. It also brought a new huge amount of data because first different systems were used, US system, Israeli system, and also the Gulf member states that were using mainly US systems, but not only. And here in this war we saw again an evolution of the warfare and the usage of space services in order to pilot, to target, and to use indeed this swarm of drones. So let's go a little bit more into detail of the war in Ukraine. I hope it is interesting, and then I will pass to Iran. I really tried to collect as much updated information. I had discussion with the Portuguese military about that, so I hope it's going to be interesting. For me, it was quite a lot. When we talk about electronic warfare, on the drone warfare in Ukraine, we talk about mainly GNSS jamming, spoofing, and the link contestation, as I already mentioned before. So something that is very interesting is the fact that nowadays, on the front line of Ukraine, but for quite a considerable amount of space, GNSS services, they don't work. So it's completely contested. So whatever engineering system you want to deploy there, you need to consider that very likely you will not be able to use GNSS. So that brought quite a lot of innovation, by the way, we will speak a little bit about that, into how to conduct and how to use these drones. And another interesting number is the amount of this fleet of mainly UAVs, not only. We are talking about thousands of drones that are brought down from both sides every month. So war in this sense became less on the front line on the people, which from one side is probably good, but quite a lot on the air and on the ground. And electronic warfare versus the positioning system and the other space services that I mentioned became more and more important. Just for the sake of competition, you have a set of systems which are used by the Russian to drive electronic warfare, about jamming, spoofing, beaconing, and so forth. So quite advanced, by the way. For link contestation is slightly different, but of course the type of attacks are similar. We are also, of course, we are talking about the jamming of the command and control signal. We are talking about the jamming, not spoofing normally, but jamming of the downlink signal, which is relevant because, of course, then if you have a first-person drone, you don't know where the drone is. You are jammed on the GNSS, you are jammed on the downlink video, and basically you lose the drone. So those are all ways by which the operator lose the contact with the drones. And of course, there are ways by which the engineering reaction managed to counter this type of attacks. And everybody know about the very famous usage of fiber optic connected to the drones in order to send them and not having them depending on the radio link. That's true, that is being used. In reality, at the current moment, we are seeing a switch towards using more robust radio antennas and so forth, which guarantee is very difficult to say, but improve the resilience to jamming and spoofing. That's also very interesting because, of course, a drone piloted with a fiber optic has a set of physical limitations which are not trivial. And in fact, another important aspect is, which is linked to another word, which in my opinion is very interesting, is the hardening of the onboard autonomy. So onboard autonomy, normally given by a set of course of action already predefined, so the improvement of the playbooks by which these drones are behaving in the mission, but very important, the use of artificial intelligence in order to give more and more autonomies to these drones, which in my opinion is also extremely scary, to be honest. At the current moment, neither of the sides in Iran, US, Ukraine, and Russia have a swarm of drones completely autonomous. But the single drones are relatively autonomous, and they will arrive there. And that's honestly is interesting, because of course also brings a new surface of attack on the possibility to poison these AI models that are driving the drones. So that's another aspect. And then of course there is the usage of the combination of a more robust radio link to connect to the C2, to the command and control center, but also backed by satellite constellation. For example, Starlink, and in the case of the US, and partially with Russia and China, also military satellites. So the combination of all of things is making those fleets more robust. At the same time, of course, the cost is increasing. So there is always a war between the cost and the resilience. Just very briefly on Starlink, because it's very, very relevant. Of course, the Ukrainians at this moment, they have a dependency on Starlink. And in the moment in which finally SpaceX decided to cut the access as much as possible, because still they have access, but to cut the access for the Russian to Starlink, their ISR, their situational awareness on the battlefield, degraded insanely. That was a major change. And I wouldn't say, of course, I'm not a military analyst for the moment, maybe I will. Of course, the recent improvements in the war from the Ukrainian side are not only driven by that, but definitely it has a very huge impact on the war. The problem is that there is a dependency, still there is a dependency on Starlink. If SpaceX tomorrow decides to close the access to the Ukrainians, then it's going to be the same. So this is very fragile, if you want. And in any case, there are Russian systems which are able to jam also the Starlink constellation, but not as a constellation, because the constellation is quite resilient apparently, but the single terminals, of course, or the single satellite can be jammed. Another interesting aspect is the fact that, of course, using Starlink or using whatever terminal that is connected to a satellite can be detected, and attacks can be triggered over the operator where the antenna is. So that's also a part which is very relevant, and that's the reason why drone operators or whoever is using a satellite terminal needs to constantly move for the risk to being targeted by a missile or another drone and so forth. Also very interesting. Let's talk about Iran and what happened very recently in Iran. Again, that was especially the conflict in February and March was really a proving ground for all these technologies. And also, and in my opinion that's very relevant, a proving ground on the initial coordination between Russian, Chinese and Iranian technologies. That in my opinion is very important because there is not yet a full coordination, maybe there will never be a full coordination, but definitely anti-jamming system has been found, not at the beginning, but after a while, within Iranian Shahed drones. So it means that there was an engineering answer from Iran towards the fact that GNSS was heavily jammed by the Israeli and the US. They went to the Russian, or probably they were already going to the Russian, and they got this technology that the Russian tested in Ukraine. So that's also very interesting in my opinion, and to be taken into consideration because things are evolving also on that side if you want. Another very interesting aspect is the fact that after a few days of the war on the last June in 2025, I think it's day 4, day 4, Iran switched from GPS, using GPS, to using Baidu from the Chinese. Because GPS was unusable. They didn't have to jam GPS, it was simply deactivated. And so clearly they didn't have navigation. And after switching, and of course this transition started way before the beginning of the war. Of course, the positioning of the missiles and in particular the long-range UAVs improved a lot. Also because Baidu works quite well or decently well against jamming. They are using directly the military frequencies, at least for the Shahed or for the most expensive drones. So also that is quite interesting. What we saw also is the fact, of course, the Strait of Hormuz, everybody is talking about that. We would have to be completely deaf and blind to not having heard about it. But what is interesting is the level of GNSS jamming that is in the region. Electronic warfare, maybe now a little bit less, but definitely in February, March was insane. And that also caused issues to the global trade, not even necessarily in the Strait of Hormuz. There are ships which reported to be in the middle of the desert or over a nuclear power plant, and I mean completely spoofed. Again, that's a consequence of attacks versus the space services connected to an actual conflict in order to limit the usage and the benefits of missiles and UAVs. So all of that is connected. And that's why I find it horrible from one side, but interesting from an engineering standpoint, if you want. So that's also something quite relevant. And I mentioned at the beginning, this initial, I wouldn't say it convergence, because it would have been a little bit too much. But definitely, as I said, Russian systems have been found within Iranian drones. Russian clones of Iranian drones has been used in Ukraine quite widely, so there was definitely an exchange. But also, well, the Baidu system from China was used in order to drive the strikes by the Iranian drones. So there is definitely a convergence in technology and in communication between these players. From our side, there was also an engineering reaction faster than what we are normally used in Europe, maybe in the US, but definitely in Europe. You probably know that the US very fastly copied the Shahed drone and they made their own version, Lucas, which is also decently resilient as far as it seems, towards GNSS jamming and so forth. But in particular, and that's I believe is very interesting, the anti-drone, the counter-drone expertise of Ukraine now is used more and more in the European Union and in the US. So those Sting drones, which you can see there, are now started being used. And in the initiative called the Drone Wall that has been initiated by the Commission, this system will be a central part of them, because instead of spending 1 million or 2 million for a Patriot missile, it's much better to spend 15K for a Sting or for a Merops, if you want. They are much more tailored to that. But again, we can see an engineering convergence between the two blocks in this sense, a little bit more loose on the Iran, Russia, and China, but still maybe stronger than what we would have expected. So let's go to the attack surface. I don't have that much time, but I should be able to manage. Let's recap a little bit the attack surface, and also let's talk about what we are actually doing as a company and a little bit also as a personal research. We divide the attack surface connected for UXVs and connected to space services, as I said, in the GNSS aspect and in the link contestation aspect. For the GNSS aspect, I already mentioned, we can count jamming, spoofing, beaconing, replay, and constellation denial. Well, like what happened to the Russian at the beginning of the year when Starlink was blocked. For each of them, now we have a huge literature, even public literature. Of course, probably the confidential and classified literature is much more. But even in terms of evidence, all these things happened thousands of times in those battlefields. So now, actually, after 4 years of war in Ukraine and what is happening in the Middle East, we have a huge set of data that we could use in order to build adversary models, for example. For what regards C2 and SATCOM disruption, of course, we can count jamming and spoofing of the C2 channel clearly, and then the jamming of the constellation providing support, backhaul, if you want, to the C2 channel, but also to whatever other service that the drones are using. And also the targeting of the operators in terms of emission. So that's also very important. And clearly, all the threats linked to the traditional threats linked to the ground segment, for example, they remain because normally in UXV system there is a ground segment, there is a command and control center, and so forth, and these are susceptible to the classical IT/OT threats. Very important is not mentioned here now, and is becoming more and more relevant, the possibility to poison the AI models which are used in order to give as much autonomy as possible to the drones. So that's also very important, and there are very actual research into that. It is partially a supply chain problem, partially, but not only. And keeping in mind, I will mention later that the engineering cycle is much faster. So supply chain and the ground segment protection is not that easy when you have weeks in order to go out with a new system. So that gives a little bit of an overview. I like very much this image. A little bit of an overview of the attack surface that I already mentioned, the GNSS, the video downlink that can be jammed and then the drone becomes a bit useless. The vision part, this is related to kinetic attacks, but if I impair the vision of the drone, the camera of the drone, basically again the drone becomes useless. There's a part related to payload and targeting that of course can be an attack vector or a target of an attack if you want. The human in the loop, well, in a war of course there is fatigue, there is a possibility that the operational DeconOps are not well conceived and built. The onboard computer, in particular for the autonomy and the poisoning of the AI model, the AI engines that are used. And then, of course, the C2 link and the SATCOM backhaul. That, I think, it's a decently good reconstruction of possible attack vectors for a modern UXV. In this specific case, that's a UAV, but it doesn't change too much. So what we are lacking, and that's where we are trying to do some research in the topic as a company, but also personally, is what we would call a TTP, which in this case would be a multidimensional TTP, technique, tactics, and procedure, for this specific type of system. Because there are adversary models, but they are mainly focused on the radio frequency part or on the kinetic part, but not considering everything. And as I said, there are multiple elements, the supply chain, the space, the connection with the space system, and then with the space TTPs like Sparta or a Space Shield. And also we have the supply chain part, the human part. There is nothing that puts all these things together, and in particular, and that's even more relevant, that is constantly updated with data coming from the battlefield. And this statement from a Ukrainian drone manufacturer, there are cases where you get the feedback from the battlefield, and in a week, you redevelop a new platform, you test somehow the new platform, maybe using a digital twin, but I would have said only once. And then you send again into the battlefield. So how can you really test everything? How can you really make sure that everything is done as it should? Those are major problems that somehow the Ukrainians managed to address. I don't think as European Union we are with this tempo, with this engineering tempo. That's also very relevant. So we theorized the elements that such a TTP should have, and at least it should be first subdivided into different type of UXVs, so underwater, sea, and the ground and aerial, because the type of threats are similar for some cases, but also very different in other cases. And then at least subdivided between kinetic, radio frequency, electronic warfare, GNSS, cyber, supply chain, human social. All of that must be connected with the traditional IT/OT TTPs, so MITRE ATT&CK, MITRE for ICS, but also the space TTPs. That's why it would become probably multidimensional. So in the very high, on the right, you see the first version that we are working on with a few colleagues in Stereo Nexova. Of course, now we have a lot of data which are public, but we don't know where we can go with the amount of data that we can collect. So we will see. But we have a few ideas. So from going towards the conclusion from an engineering policy response, definitely protecting fleets and swarm of UXVs is also possible from a more traditional cyber perspective. So for example, reinforcing the supply chains and also improving reducing the emissions of the operators of the drones and so forth. So that part remains a little bit more traditional. Also reinforcing the ground segment is also quite relevant. From a policy perspective, oh no, I was forgetting. A problem that has been highlighted is the fact that the actual OSNMA system, which is provided by Galileo, which is quite good for spoofing attacks, at least on the GNSS. The adoption of it, of course, on the defense sector, on military drones, they normally use PRS, so it's even better. But the commercial drone, the adoption is very low. And something that I didn't mention, but we all know, is that the modern war, especially on the front lines, so not too much in Iran, but definitely in Ukraine, is conducted not only with military drones, but with commercial drones which are repurposed for dual use. And in this case, having an OSMA receiver is very important, but it's not the case for most of the technology that is out in the market. So an improvement in this sense will be needed. In terms of policies, talking about the European Union, well, we have a so-called drone strategy, which will be connected to the drone wall that has been promoted by the Commission, but for the moment is mainly linked to commercial drones. And then, of course, for what regards the ground segment, for what regards telecommunication, the classical standards and frameworks, NIS2 and the EU Space Sector are trying to protect and also doing a decent work, I would say, this type of system. But there is nothing, again, specifically dedicated for unmanned systems, which is quite relevant. So, briefly what we are doing, we had a very nice experience with ESA related to the simulation of swarm of drones and unmanned management system within our cyber range digital twin. So we were able to replicate an interesting set of attacks and also the response, the related response. Here you can see, and if you want, you can pass to our stand and we can definitely discuss. So there was a full digital twin, second time that I say that, a full digital twin of swarm of drones, their command and control network, and also a set of SDRs that we are using in order to simulate in a quite realistic way GNSS attacks and also attacks on the C2 link channel. And something that we will start in November, linked to the idea of developing this TTP for UXVs, connected to the space TTPs and to the others, within a European Defence Fund. Within this project, we hope we'll be able to get at least EU-restricted information, because the project is EU-restricted, and complete the TTP with more data than what the ones that, at least a version 1 of the TTP, with respect to the ones that are publicly available. And to conclude, very briefly, well, I hope that I demonstrated that drone warfare is very connected to space systems. The constellation migration is quite important now, and it became a big change in the way in which we conduct war. Modern system linked, for example, to the Galileo services could be a game changer, can be a game changer within this type of warfare. And also the engineering cycle, at least in war, but also probably in peacetime, for this type of system became extremely fast. Then we have, as Europe, we have definitely the knowledge. We have definitely a set of basic, or well, even not basic, but a set of policies that we could use. But what we are missing at a European level, despite all the initiative from the Commission, like European Defence Fund and so forth, for a coordinated work on these technologies, not in 5 years, but in 1 or 2 years, because these are the technologies that will shape, hopefully it will not happen, but whatever is going to happen to the European Union from a war perspective. Thank you.
Thank you very much, Mr. Merialdo. I invite you just one question. We can't let you go like that. Thank you very much for this comprehensive presentation. It was really captivating and highly stimulating. Also, the advantage you use that of being a personal, well, conducting personal researches, and also that of your professional experience at Nexova. When listening to you, given that you've analyzed and had access to data from Portuguese military, and I imagine also you've been conducting interviews, and without unveiling any top secret.
No.
We wouldn't want you to feel uncomfortable, but my first question would have been, do European industries and public actors actually understand how swiftly the battlefield is evolving? But then you answered about how counter experience of Ukrainian was also inspiring Western powers, the US. You've told about their experience, and you mentioned that Ukrainian were able to test everything, and that the European Union was, well, might be in need of a change of tempo. You've offered solutions about coordination, but what do you see? Because this is a forum of dialogue, and we've heard a lot about those initiatives for cooperations also in agencies. What is still the obstacle to this change of tempo and further cooperation?
Well, I think that we are still, I think there is now a better understanding of the pace where the engineering cycle needs to now move. And of course, the engineering cycle in Ukraine is that fast because there is a war. But even in peacetime, we cannot think anymore about 2 years to define requirements, 3 years to define design, and then implementation, and then you have a CDR that gets prolonged for another year. That's not anymore possible. Maybe for some space system could be still, but for this system is completely impossible. I think there is a realization, but what I saw, unfortunately, is that a good part of the measures seems to be too reactive than proactive. So the drone shield, I think it's a good initiative. It's trying to use the European technology, but I had the impression that was a bit rushed on the, I wouldn't say in the last moment, but I'm not sure that was really well planned as it should have been. On the other hand, it's good that there is such initiative. In my opinion, it's good not only from a security standpoint, a security of the EU, of course, but also from a technological standpoint, assuming, and that for me is one of the most important items, that in the rush of building something, we are not going to buy that something elsewhere, because we need to develop that something here in Europe, as much as possible with European technologies. And that's something that from my understanding of the EU military, several military understood. Some of them, they don't have too much the means to push on technology, but others are relatively fat in terms of the German, for example, MOD is investing quite a lot of money. My hope there is really we will try to be as European as we can, because we could. Maybe we understood that the tempo increased a lot. I don't think we are completely there in terms of the regulation, the agility of the regulation, but also the frameworks that we are using. But I have the impression that there are improvements. Fear a little bit pushes the boundaries, yes.
We are prompted indeed. Thank you very much. We can give you another round of applause. Thank you also to Nexova for its continued support. I'll take the microphone.